Hello everyone, welcome to TriRide, the new era of learning. This is SAT 365. In Module 2, we are discussing about greedy-based first search algorithm in AI. Let's move into the topic. So in this topic, we learned about what is the greedy-based first search algorithm and how greedy-based first search all works and applications of greedy-based first search and advantages of greedy BFS and disadvantages of greedy BFS. And overall total, we discuss about conclusion. So now, what is a greedy based first search algorithm? Greedy based first search is an AI search algorithm that attempts to find the most promising path from a given starting point to the goal. It prefers path that appears to be a most promising regardless of whether or not they are actually the shortest path. The algorithm works by evolution, evaluating the cost of the each possible path and then expanding the path with the lowest cost. This process is repeated until the goal is reached. So here we use some kind of strategy to reach the goal in a initial state, right? In a few first like we start with some starting node and we until that we pick up some least to pick up some the least in values and then we reach the final goal to efficiently reach just easiest way to reach the goal point. So the algorithm works by using an heuristic function to determine which path is the most promising. The heuristic function takes into account the cost of the current path and the estimated cost of the remaining path. If the cost of the current path is lower than the estimated cost of the remaining path, then the current path is chosen. This process is repeated until the goal is reached. So whenever we want this heuristic function uh, takes down the process and until we didn't reach our goal state, the process will still continues. The loop will be continuous. When we find our and find and reach our goal state, so the loop will be break. Here we discuss how greedy based first search works. So greedy-based first search works by evaluating the cost of the each possible path and expanding the path with the lowest cost. This process is repeated until the goal is reached. So the greedy-based first search is an algorithm that aims to find the shortest path, a goal to by making closing like we can say making locally optimal choice to each step. So it has an evolution path here. We can say the evolution path here. So in evolution path, it does the cost of the each possible path from the current node. This cost is determined by the heuristic function. So the algorithm uses the heuristic function to determine the which path is the most promising, right? It evolution of the paths. The algorithm evaluates the cost of the each path, right? So in this second scenario, we have the path expansions. So in this path expansions, um, it then expand the path that has the lowest cost, like the most promising path according to the heuristic. So the heuristic function takes into the account the cost of the current path and the estimated cost of the remaining paths. We have the iterative process here. So this process of the evaluating and expanding the lowest cost path. So it repeats until the goal will be reached. So here we can say heuristic function like this is this is crucial part of the algorithm. The heuristic function estimates the cost of the current state to the goal state. It helps to determine which path is the most promising and by taking into that. So in the cost of the current path and the estimation of the current path, like we used to select the path, we use the path selections in the cost of the current path is estimated. The heuristic is the lowest than the estimated like that. So in the cost of the current path is the lowest, then the estimated cost of the remaining path, then the current path is chosen. This process is repeated until the goal is reached. So we can say here we use the path selection process. We already discussed it. So it chooses the if the cost of the current path is lower than the estimated cost of the remaining path from the other potential paths, then the current path is chosen to the further exploration. So it used to expand the um, you choose to expand the overall node. So in essence, a grid-based search is a greedy because it has always chosen the path that appears to be the best and the current moment based on its heuristic estimation, and without necessarily considering it's a choice which lead to the globally optimal solutions. So its primary goal is to reach the goal as much as quick, as much as possible by prioritizing the and strategy it follows with the shortest path. So an example of the BFS algorithm is below graph. Suppose we have to find the path from A to G. So here we have a path. So in this path, we want to find the directions. So we want to find the A to G value. So here A is our starting value and G is our goal value. We want to reach the goal state by traveling this road. So we want to consider the shortest path to the reach our goal. Okay. So let's start. So the value in the red color represent the heuristic values of the reaching the goal nodes. G from the current node. So we are starting from the A. Okay, here we can say we're starting from the A. So from the there is a directed path to the node B, right? So with the heuristic value, we have C. So what is the value is begin here, right? So let us wait. I will explain you. So here we consider the problem of f of like this. Here we considering the problem like we can take us we can consider f of x equal to we can consider here equal to f of x equal to f of xx. F of x equal to f of xh, right? So here what we did is, so here we can did like this. So what the process will we make here? So in the first f of x also equal to h of x, right? So we consider the h of x here. Wait a second. So what will the directions? So we have h of x equal to, so h of x equal to we have a, right? So a is 40. We are starting node h of x is a. So a equal to 40. We have a equal to 40 and same we have how many neighbors will connected to the a. So we have connected nodes, we have b and we have c, we have c and final we have three nodes, three neighbors were connected to the starting node. So what are the values of those nodes? I want value. So here the values of the those node is, so b has 32. So to C has 25 and D has 35. So in the three values we can consider here, we have 32 has B and 30 and B value, 25 has C and 35 has D. So here what we did, we considered the mean of the number, right? We consider the mean value. So to follow easy to take a easiest short way. So 32 is we can say that 32 is greater than 25, right? 32 is greater than 25, and 25 is less than 35, right? So here 32 is greater than 25 means we can consider here mean value. What the mean value to A and D we have 25 has a mean value, right? So we pick the C has the mean value. So we pick C has the mean value. To reach the goal state here, we can see it takes the goal state from the start value to here. So it pick the 25. In next stage, it will be considered. So in the next stage, we have C. So C we have 17 and 19. We have h of x equal to here h of x equal to 17 and 19, right? So like it. Here we consider in next state it considered like the same. So as per as the best first search algorithm, choose the path with the lowest heuristic value Currently, C has the lowest value among the above nodes, so we will go for the A to C. So in this current node, what will happen? So same process repeat until it finds the goal state, right? So the same process will repeat until it reaches the goal state. So here also it starts with the same process until it would didn't. So here also we can see here. So C we have the f of C, right? So for f of C we have. So for the f of C we have. You can see here. F of C we have connected neighbors, or what f of f we have. F of f we have, and f of e we have, right? So here, what the values of the f of f? It has 17 and it has 19. So in the 17 and 19, we consider in the 17 and 19, we have two neighbors. So we want to travel, we want to take the one neighbor here to move forward. So 17 is less than 90. So 90 is greater than 70, right? So here we consider the value of 19. So 17 is smaller than 90. So it chooses the shortest path to move quickly to the goal value. So it easily consider that 17 has the shortest path. So it chooses C to F. And after that, we have connected loop as same. Yes. Again, the next step. Again, next step. Now we consider here. So here we can easily, here we have a tricky. Here we can see that. So here we have f of x, right? Sorry, f of, here we have f of x is f, right? Now here f of x is f. So from the f, we consider here f of x equal to, we consider here, so it consider f of g. We have three neighbors here too. So we have first has d, and second we have c, and fourth we have, sorry, third we have g, right? So we have the values here. So we have the values, right? So here we can see f of c, f of d we have 35, because here we won't directly consider. We did not considering any mean value here. So that's the concept I want to explain you. So we can see here, we already visited d, right? We already visited the d. Here we can see we already visited, we didn't visited D, but the goal is forward to the G. We quickly reach to the zero. So in the case, what it's done actually, so it rejects D. And when it comes to C, C is already visited. So it also rejects the C. It looks look after that. So we have to go reach zero. We can easily find zero and it reaches to the zero, right? It has a mean value when compared to 35, or comparing to its mean value, or it is our final goal state, right? So here what we have, we want to reach the G when G equal to zero, G equal to zero, like we can say the our goal, G equal to goal, right? So G equal to zero. So G equal to our goal equal to also G. When its goal equal to G of zero, it will take G of zero value I'm considering here. So in this condition, our goal it reaches. So it doesn't move to H9. So it picks the easy way to quickly reach the goal state. So this is the process we can take here. It is the really best for such in heuristic function, heuristic method. So now the goal node G has been reached, and the path we will find follow A to C and C to F and F to G. So here we consider the applications of the greedy best first search. So, according to application, we can say that a greedy best first search is a versatile algorithm used in various domains due to the efficiency in the finding good enough solution quickly. Even not always the absolutely optimal one, but its primarily strength lies in the ability to quick explore promising paths based on the heuristic. So in it we have pathfinding. In pathfinding, we can say that this is one of the most common application greedy best first search is used to find a path of the often shortest between the 2 points in the graph in a map. It usually mostly the graph it used in many applications such as video games, robotics, and navigation systems. So machine learning, greedy first search can be used in a machine learning algorithm to find the most promising path to a search space. So it uses to navigate the complex search space. Those search spaces often they represent the different configurations, parameters, or features for the model, future of the models, and the algorithms help to find the most promising path to those configurations to optimize a machine learning models to achieve the desired outcomes. In optimization, greedy best first search can be used to optimize the parameters of the system in order to achieve the desired result. So we have this application involves using the algorithm to optimize the parameters or settings of a system to achieve the desired results. The algorithm explores the different parameters and combinations guided by the heuristic that indicates the closest particular set of parameters to the optimal outcomes. So we have game AI. Greedy based search can be used in the game AI to evaluate the potential moves. So it is especially within the game artificial intelligence. Greedy based search is valuable for the evaluating the potential moves for AI agents, character component, sorry, we can say characters and the opponents, and choosing the best one of the best like that. So navigation, GFS can be used to navigate to the people. Sorry, navigate to the find the shortest path between the two locations. So navigation, we all know that to find the best path in the directions. So it is closely related to the path finding, but often refers more broadly to the system to help the people or vehicle move from the one place to another place. Like best first search helps identify the shortest or the most efficient path between the two locations. And NLP, we also know the natural language processing. Greedy based search it can be used the natural language processing tasks such as language translations or the speech recognition to generate the most likely sequence of the word. So NLP is the best greedy based first search can be used to task that involves generating the sequence of the word of the making the decisions based on the linguistic content. It algorithm helps to generate the most likely sequence of the word choice by evaluating probability in the each step in the image processing. We all know that the image processing and it has its own application it has its own identification. Image processing 3D based search can be applied to a segment and an image into a different region of um, interested. That often involves the grouping pixels together and they that share similar characteristics, color, texture, intensity based on the heuristic that defines the similar or to a region. So all over that particular algorithm for the problem, we quick the historic driven search for a good solution and more to very graduating the absolute optimal solutions, especially in a large search space. So what are the advantages of the greedy based search algorithm? So we have simple and easy implementations. The logic behind the greedy based first search is a relative straightforward. It primarily involves the maintaining a priority queue, right, of the nodes to visit the ordered by the heuristic values and repeatedly expanding the nodes to the lowest heuristic cost. So the simplicity makes it easier to understand the code and debug the compared to more complex algorithms. Fast and efficiency. It prioritizes the nodes that appears to be the closest to the goal according to the heuristic greedy best first search. Often find the solution very quickly. It avoids exploring path that seems less promising, leading to the fewer nodes being expanded compared to the uninformed search. algorithm like best first search or the depth first search in many scenarios, and low memory requirement. In low memory requirement, it compared to the algorithm like best breadth first search, which might need to store all the nodes at the given depth. Greedy best first search, typically it has a low memory requirement. It primarily needs to store the nodes in the frontile. So which are the candidates to for explanation? It heuristic is a good. This reason this list can remain relatively small, and we have flexible, and the flexible the algorithm effectiveness it largely depends on the heuristic functions used, and the flexibility allows it to the adapted to the wide range of the problem it by simplify designs and approachment heuristic, and different heuristic can be used for some of the prioritized accepts. It uses the shortest path and the fastest path versus path with the fewest turns. It has its own flexibility and efficiency. While efficiency is fast and efficient was the already listed, efficiency has the separate point might emphasize its performance in the terms of computerization resources. So we can set the time and memory for finding the solutions. It efficiently because it has aims to directly for the goal guided. So it makes the suitable for a problem with a large search space where finding an optimal solution might be computerization influence and directly for the goal finding. So we have disadvantages of the greedy. So here we have inaccurate result like where the greedy BFS is greedy in approach. It always chosen the path and appears the best current movement according to the heuristic function without considering the long-term consequences. So local optima, this is the closest related inaccurate result. The algorithm can get stuck in the local optima, meaning it reaches a state where any immediate move appears worse than the current state, even through the much better solution existed. So heuristic function we have explaining the performance like for the perform the effectiveness of the greedy based first search or having heavily depended on the quickly like poor heuristic difficulty in design like that. So we have lack of completeness, like very besters not granted to the find the solutions even one existed. So it especially true in efficient search space or in the graph with cycle. Uh, it repeatedly leads to the search away from the goal or the into a loop. It does not systematically explore all the possible paths. It only uh, explore the specific path to reach the shortest direction it takes. So it doesn't consider all the paths. So overall conclusion here. Greedy based search is an AI search algorithm that attempts to find the most promising path from a given starting point to goal. So this algorithm works by evaluating the cost of each possible path and the expanding path with the lowest cost. This process is repeated until the goal is reached. The greedy BFS has several advantages, including being simple and easy to implement, fast and efficient, and the having the low memory requirement. However, it also has some disadvantages such as inaccurate results, local optima, and requiring a heuristic functions. Greedy based first search is used in many applications, including the pathfinding, machine learning, and optimization. It is useful algorithm for finding the most promising path to a search space. So I hope you guys all of you understand about the concept of the greedy based first search in AI algorithms. So that's it for today. Thank you.